Objective 9, more limits, part 1. We'll have a part 2 to this section, but for now we'll go through at least the beginning problems. Just to review, limit as x approaches 2x squared plus 3x. First plan of attack for limit, substitute 2 times 2 squared plus 3 times 2, and that's equal to 14. That is the limit. That's the answer. Limit as x approaches 5, x squared minus 8 over x minus 4. 5 squared minus 8 over 5 minus 4. 25 minus 8 is 17 over 1, or 17. That is the answer. Limit as x approaches 2 squared minus 4 over 2 minus 2. 0 divided by 0. That's indeterminate. Really doesn't tell us what's happening. So what do? We factor x plus 2, x minus 2, and we get x plus 2, and then we take the limit x approaches 2, x, and we get 2 plus 2, or 4. That's the answer. Just to go a little bit further here, if we get 0 divided by c, c is not equal to 0, that's a determinate form. The answer is actually 0 for that limit. And if we get 0 divided by 0, we call it an indeterminate form. You really cannot tell what happens. The limit may exist, the limit may not exist. You have to reduce, try again. Now here's a new limit form, c divided by 0, c is not equal to 0. That's what's called a determinant form. We can determine what happens based on that. It turns out the limit does not exist. And here are a couple examples. Show the following limits do not exist. Limit as x approaches 4, 2x over x minus 4. We get 2 times 4 over 4 minus 4, 8 over 0. That limit does not exist. We'll just say D and E. End of story. We can go no further with that. Limit as x approaches 2x plus 3 over x minus 2. And we get 2 plus 3 over 2 minus 2, 5 over 0. Limit does not exist. End of problem. Now this is worthy of a little bit of explanation here. Since we've already graphed a rational function like this, limit x approaches 2, x plus 3 over x minus 2. We can say a little bit more about this. Specifically, if we have limit x approaches 2 from the right, x plus 3 over x minus 2. Recall, 2 is a vertical asymptote. This means from the right. If you draw a little number line here, there's 2, there's 3, there's 1. From the right, a number just to the right of 2 could be 2.1, for instance. If you take 2.1, substitute it, that would give you 5.1 over 0.1, which is 51. It's pretty clear what's happening here. There's that vertical asymptote. This is headed up to positive infinity. And so this right-hand limit we can say is plus infinity. And in a similar fashion, if we have limit x approaches 2 from the left, x plus 3 over x minus 2. A number right to the left here could be 1.9. And plug 1.9 in, and we get 1.9 plus 3 over 1.9 minus 2, 4.9, negative 0.1, negative 49. You can see what's happening. We're headed downward. This is negative infinity. Negative, I forgot the negative here. So just to clarify things, we have this limit as x approaches 2 does not exist. We have, let me come front and center here. We also have limit x approaches 2 from the left, x plus 3 over x minus 2 is minus infinity. And here we say this limit just does not exist. Infinity is a form of does not exist. Negative infinity is a form of does not exist. Okay, this is just more descriptive. This tells you how it doesn't exist, and this tells you how it doesn't exist. In this case, you can't say plus infinity or minus infinity because it goes different directions depending on whether you're looking for the right or the left-hand limit. But nonetheless, if we had a limit that was infinity, that's just another way of saying does not exist. It's being specific about how it does not exist. Okay, that's all for part 1. We'll be back with part 2 shortly.